Hi, welcome to another edition of a Design Spark interview. Today we are joined by Darren Lewis of OpenVent and also Camilla, who is one of the RS employees who is actually working on the project. Hi guys, welcome to the Design Spark interview.
Hello, hi Greg.
Hello.
So Darren, can you tell us a little bit about OpenVent Bristol and what its mission is?
Yeah, absolutely. OpenVent is an open source ventilator, and we're designing this to be suitable for developing countries because it's very simple and can be produced rapidly. So rapid manufacture has been the whole ethos of the design from the beginning, and the way that we enable that is by having a very simple design, which is based on just readily available components and readily available manufacturing processes, so that it could potentially be built in pretty much any country in the world using quite simple techniques. So we try and make it as simple as possible, and tailored just to treating COVID and a few other similar things.
Okay, so
In short, that's what it's all about.
yeah, if we go back to maybe 14 months ago, there was a lot of obviously the pandemic in the news and the need for ventilators and PPE, etc. So, what was it that actually inspired you to actually start this project? Was there any particular one point that you can reference?
Yeah, well, for me, over in the UK, there was what the government called a ventilator challenge. It was back in March in 2020. So it was the premise that we didn't have enough ventilators in the UK to treat COVID, and we needed a lot more. So the government were bringing in companies that didn't usually produce ventilators to try and design new ones, which could be made very simply and very rapidly. But I soon realised that there was a lot of sort of bigger companies that were getting involved with this, particularly ones that are used to designing medical devices, which makes a lot of sense. And I soon found that there was an untapped part of that demand, which was more for developing markets. So the more wealthy countries were fine because they could kind of afford to buy the more expensive units and develop them. But the less wealthy countries weren't being catered for as much. So that's where I wanted to come in with an open source design that a lot of people could contribute to, which we could produce very cheaply, but at the same time make sure it's safe for use and suitable for use.
Yeah, and I guess you're talking about locations, in vast countries which don't necessarily have the infrastructure. I take it this would be a viable solution as well.
Yeah. I mean, one particular advantage of our ventilator compared to existing ventilators tend to run off a compressed air line that runs in the hospital piping. Our design has a compressor built in, so it doesn't need that. So in that way, it can be used in more remote locations. And the fact that it's quite small and rugged and it only does what it needs to do, is very important because the more parts there are, the more things there are, the more complexity and the less portable and robust it is. So
And
yeah,
the
part
cost.
of that design is making it small, compact, robust, sort of rugged, so it could be used in more locations with less infrastructure. That's right. Yeah.
Okay, and obviously, we're all aware of this pandemic starting out at the beginning of last year. So, how long have you actually had the project running, and what's the current state you're in with this project?
As soon as the ventilator challenge in the UK kicks off, that's when I started to work on this, which was back in March 2020. So I've been working on it a good while now. So in the short term, it was just me in the beginning, where I was building the initial prototypes and kind of doing the electronics, the software, the mechanical design, and communicating with people. And then gradually, I had more people who wanted to get involved and help out. And then there was kind of a good solid team of 4 or 5 of us for a few months. And then after that, we joined in with another organisation called Helpful Engineering, who greatly helped us because they were able to give us some more resource and also help us recruit people as well. And the stage that we're at with the project now is we've completed all the mechanical design, and we're waiting on the finishing touches from the electronics so that we can produce our circuit boards, which are being produced by a company that are sponsoring us, which is great. And we're waiting on the software that goes in those circuit boards. Once we have those, we can build up the final units, which we'll send over for testing. You could sort of call it compliance testing against one of the ventilation standards. and then at that point we can launch the project again with the final version to our website, at which point any medical manufacturer, if they wish to, they can take our design as a starting point and either begin to manufacture it, or they can make their own tweaks and their own changes to it based on what they want to do with it. But it will all be freely available, open source.
So I guess that's the power of open source, isn't it? Is when the need arises and you need to meet the demand, that you can actually share designs and get things up and running quite quickly. So what would be kind of your long-term plan for OpenVent?
Yeah, I think this kind of situation, although it's obviously not desirable what happened, but the silver lining is that I think it's uncovered a bit of a need for open source medical devices. So there hasn't really been, at least to my knowledge, any open source medical devices out there previously, which my guess is mainly due to the compliance challenges that come with medical devices. So medical devices need to be safe. So there's a lot of standards they need to meet to prove that they're safe, and there's a lot of like hurdles along the way, which are not only cost a lot of time, but they're expensive as well. But going forwards, and all of the collaborations I've had with other teams that want to work on the same things, medical devices are a brilliant cause, and people love to work on medical devices because it feels like you're doing something good, which is brilliant. I think going forwards, I think we're seeing a bit of a movement where more and more people are beginning to design medical devices as open source, because the compliance challenges are still there, yes, but you can kind of manage that in the right way. Where if you can design something yourself based on those standards and release it as open source, then the medical device manufacturers can always pick up on your design and kind of take it the last step of the way. The medical device manufacturers are the people who are responsible for validating and making sure it's safe. But there's still a lot that the open source community can do to innovate in the short term. So there are organizations such as Helpful Engineering and Public Invention who are doing that a lot right now. And it's not just ventilators that they're looking at. There's all sorts of medical devices that they're aiming towards. So they're trying to build a bit of an open source infrastructure to design lots of medical devices as open source going forwards. Really interesting time.
Yeah. I was going to ask you a little bit about the challenges. Obviously, compliance and testing and maybe certification is one that you've just touched upon. But is there anything else with the challenges that you've met during this OpenVent project that you maybe weren't aware of, or things that you've learned since the project started?
Yeah, I mean the challenges with device safety and compliance. Yeah, I've already touched on that, and that is a big thing, and it does make it very tricky for open source projects because to push forwards through that is quite expensive. I've already mentioned that. The other aspect which I found particularly challenging, at least compared to my day job, is I guess kind of pushing things forwards with a volunteer resource. So it's often quite tricky to plan for the future and to understand, at what point in the future you're going to be at what place, because people can only give the time that they've got because people are volunteering because they want to do it, which is brilliant. But at the same time, it makes it in some ways more challenging to get people involved in the first place because people have to work around their own commitments. I'd say that's quite a big challenge, and I've kind of learnt a fair bit of how to deal with that. Yeah.
So you mentioned earlier there was like a core group of 4 of you at the initial stage. So how have you actually brought more volunteers on, and what is it those volunteers are adding to the project? For example, are we talking about design, programming, etc.?
Yeah, from fairly early stages, I was posting things out on LinkedIn and on social media, and some people I'd never met were coming forwards and asking if they could help with the project, which I thought was absolutely brilliant because it shows that people want to help out because they can see it's for a good cause. I think that's amazing, and it's people of all sorts of skills. So it's everything from mechanical to electronics to software, and compliance, risk management, project management, kind of all the positions that you would find in a top class engineering consultancy or engineering company. Those are the kind of skills that we're able to get. And one big help that really pushed that forwards was collaborating with Helpful Engineering, because they have a volunteer recruitment team who are putting job adverts on sites like Indeed and similar sites to that.
Okay, so Camilla, I'm going to bring you into the conversation now. So most of our Design Spark audience will recognize you from a lot of the content you've produced for us. So could you just tell us a little bit about your involvement in the project, how you came to be involved, and what your role has been in this?
Sure, yes. So as Darren mentioned, he posted a lot about the project, but the way I found it was also through LinkedIn, but through my personal connection with one of the existing members of the group. She was working on the electronics design for quite a while before I joined. And when I saw on her LinkedIn that she's part of this project, I was like, oh, this sounds amazing. Can I join, please? And yeah, that's how I got involved. Well, my background is in electronics engineering, so I was able to use some of the knowledge I picked up at university and at my current role with this project. Yeah, it's been I have been a member probably up until a few weeks ago. As Darren mentioned, it's a big commitment in terms of time, and I was devoting at least 8 hours a week, and it quickly added up. And after 4 months, I think I had to leave because of some other commitments. But in general, it was a great experience. And in specifically in electronics team, we had professionals of at varying levels. So we had entry level and senior level engineers, and it was great to be part of the team and learn from the best, as you might say, and always get feedback. It was very supportive environment. And yeah, I think it's a great initiative overall, and I learned a lot from being part of it.
Great. So it sounds like you were really involved there, and obviously all the skills that you have, you can then put to great use as well. So that's really commendable. So just in terms of volunteers, Darren, are there any slots available right now? Is there anything that you're calling out for, and how would volunteers get in touch, for example?
Yeah, absolutely. There are some positions that we're looking for generally in the areas of electronics. So I think we have a job ad out for an FPGA engineer as well as electronics, and there may be something in C programming for microcontrollers, embedded microcontrollers as well. If anybody wants to find out about that, the best place to go is to the Helpful Engineering website and look for vacancies for projects, and there should be vacancies for OpenVent Bristol on there, and there may be a couple of vacancies on Indeed as well.
Mm-hmm.
Great. So Camilla, you mentioned as well, some of the things that you enjoyed about this project was working with other engineers from entry level to the seasoned professionals. So what lessons can you personally take out of being involved in this project, and what advice would you maybe give to somebody who's thinking about becoming involved in the project?
I would say that being able to use the knowledge, the theoretical knowledge that I picked up from university in a real project was a big win for me. And it wasn't something I was designing just for the sake of like getting a grade. It was something that will go into a real device and possibly save someone's life. So it was a big motivation for me. And I mean, you every time you show up and you are motivated to do your best to do the right job, and not just for the sake of doing sort of any sort of other projects. I would definitely encourage anyone who are, even if you're not sure if you can do it, maybe try. And there must be something you can do in the project, even if it's something small, but you will contribute to it, and you will also learn by being part of the team. You'll learn from other engineers. You'll pick up the skills that you didn't know. That was a thing for me. I, for example, learned how to I learned about JTAG interface, which I haven't used before, and there was something that I couldn't do probably for a couple of weeks. I couldn't figure out how this thing works. But I had few attempts, and then I got feedback from senior engineer, and I figured it out. And I don't think I'll ever forget how to do JTAG interface now. And so it's like the whole learning loop was completed, and like this project definitely showed me where I probably lacked some knowledge, and I was able to pick up that knowledge on the way while I was doing project, while I was designing the circuit with the rest of the team.
That's great. So Darren, if I'm not mistaken, there might be something behind you that you could maybe show us regards to the ventilator.
Absolutely, yeah. I can talk you through that. So the device that you see behind me, I'll put the camera a little bit closer so you can see it a bit better. This is the current prototype ventilator that we have. So I can switch it on, which I'll do, so you can see it working a little bit. So we expose the top panel of the ventilator, which is this transparent plastic that you see on top, because you can see the way that it works. And very simply, we have this device here, which is called an AmbuBag. And an AmbuBag is a manual respirator. It's designed so that somebody can place one end of this over a person's face with a mask, and then with their other hand squeeze the bag and manually respirate somebody. And the way that we're doing this in our ventilator is we're very simply replacing the hand that squeezes the bag with a mechanical hand. So there's an arm, a high torque motor connecting the arm to the bag, and it's just pressing the bag down and releasing it. But so that's kind of the simplest mechanism that we could find for doing that. But it's all tied together with a sophisticated control system, which will be done in the circuit board, which will go behind this front panel here. So we'll have two kind of displays on each side. One that will be used for measuring the different parameters of the ventilation sensors on the left, and these are the kind of things that a doctor would be looking at while they're using the ventilator. And then on the right, these are going to be for setting different settings to the ventilator. So you could set the breath rate, the oxygen level, the driving pressure, things like that, and then a few buttons to control that. We have two ventilation modes, and the reason that's important is back in March last year, people were being put on what's called a mandatory ventilation mode, which is when the people have to be sedated and intubated. So that means a tube goes down somebody's throat, they're sedated and ventilated. But it was quickly found that that was not the optimum way to treat patients initially, because it tends to lead to quite long recovery times. I'm just going to switch that off so you can hear me a little better. It does make a little noise. That's how you know it's working, because it's got a noise. But we have another ventilation mode available, which is called a spontaneous mode, and that's where it can sense that the patient wants to take a breath, and then the ventilator starts to begin the inhale and exhale period when the patient wants to breathe in and out. And the advantage of that is it means that people can be put onto that mode without having to be sedated, and that means there's a much shorter recovery time from that point to the point where they're fully recovered, and a much higher chance of recovery as well. So now that people have learned a lot more about how to treat COVID, they would tend to put people on that mode of operation first before they put them on the mandatory ventilation, and also the spontaneous mode where they sense breath. That's also used as part of the recovery process from the mandatory mode. So it's really important that we've kind of got that mode working on our ventilator.
That's great. That's really impressive to see what you've done there, and talking us through how the project's progressed. That brings me on to my next question. We mentioned earlier that you were, this is the prototype version, and you're sending boards for manufacture. But what is it now at this stage of the project? What kind of support do you require? If you were to call out, what would be those areas of support that you're now looking for?
Yeah, in particular, we're looking for people to help with the electronics, because that's kind of the last part of the puzzle that we need to complete. So that includes those kind of positions I mentioned earlier, microcontrollers, FPGAs, as well as PCB design and general electronics, those kind of skill sets. But also we're kind of scraping along with minimal funding, so we do have a crowdfunding page, cheeky plug there. A GoFundMe page.
We'll put the links in. We'll put the links in.
We're surviving just from charitable donations from either individuals or companies or organisations. We've had various companies sponsor us with with both funding and materials, and that's what's keeping us going. So so both of those things is what we need to kind of get to the last stage of the project.
Right. Okay. So yeah, there's still a way to go. Yeah, in a space of, you know, just a little more than 12 months, you've come such a long way with this. So my last question to you is, what do you see being the long-term objective for OpenVent? You know, as you guys mentioned, you both have day jobs, for example. But I would imagine, you know, as this gets more traction, do you see OpenVent becoming like the benchmark for this type of thing in the future? And what other maybe avenues are you exploring with OpenVent?
Yeah, well, I mean, I guess a couple of things. One is I don't think there's a need only for this type of thing due to COVID, and that can be seen because ventilators aren't just used for treating COVID; they're used for treating for lots of purposes.
Yeah.
That can partly be seen by looking back at the beginning of the pandemic, where some countries who started to be hit by COVID really didn't have enough ventilators to go around at all. And in particular, we had a big spike with Brazil right now. COVID, I mean, India are struggling quite a bit as well. And there's just nowhere near enough ventilators that they have already. Ventilators are traditionally very expensive, £20,000 and upwards for the sort of standard ICU spec one that you'd see in a hospital in the UK. So going forwards, this type of ventilator might fulfill a need for other purposes in future. Having something that's kind of lower cost but simplified but still safe, and the fact that it's open source as well means that sort of fully fledged medical manufacturing companies can build upon the design and keep things moving forwards. So I think I genuinely think there could be a need for this kind of product, which is fulfilling its own niche going forwards. But as I said before, not necessarily just ventilators. I think open source medical devices in general are becoming more and more of a thing, and more people are working on that as a general topic, which I think is great.
Yeah, fantastic. I love the work that you guys are doing, and I hope we can, you know, join another conversation and see where we are sometime in the future and have you back on Design Spark. So Darren and Camilla, I really thank you for your time today and sharing your experience and the great work that you guys are doing with OpenVent Bristol. Thanks a lot.
It's
Thank
been
you for
great to speak
inviting
to you
us.
both. Thank you.